Welcome back to this edition on tutorial. At this time, we are continuing our work on inequalities. At this time, we are starting with quadratic inequalities. And here is a question that states that given that x is not equals to 0, find the set of values of x for which 2 over x is less than 1. Solution. A student may think that, he can multiply both sides by x in order to find the value of x. To do that, it will be a grievous mistake because at least you lose one value of x. So if you have such equation like this is how you do it. In fact, we'll solve so many examples of these to make you more familiar with such kind of questions, so that you wouldn't struggle with you are not going to struggle whatsoever. So if you have such an equation like this, you can say that 2 over x is less than 1. This equation, to do this, if you have an expression like this, the best way to do is to multiply both sides by x squared. So in that case, I'll say multiply both sides by x squared, in which case we have 2 over x being multiplied by x squared is less than 1 times x squared. So with that one, we will have this one to be 2x is less than x squared, which is not different from 2 minus x squared is less than minus x squared plus 2 is less than 0. Very good. If you have it this way, I think there are two ways to go about at this point. You can go straight away by using this equation. In that case, you can see that it is a quadratic equation in x. Oh, sorry. This is 2x less than 0. This is a quadratic equation in x. So, because the coefficient of x squared is negative, it indicates that the curve will have a maximum value. By the way, it was just recently we did an extensive work on quadratic equations. So this one will be something you may be familiar with. It is not a big deal at all. Having something like this, you can see that the coefficient of x squared is -1, or the coefficient of x is negative, which indicates that the curve will have a maximum value. But in the meantime, if you factorize s outside, and then you can have x plus 2 is less than 0. Very good. Let me see my screen, whether you can see properly. Yeah, I can see on my screen that you can see properly. So, to do that one, you can see that there are two values of x, which is x equals 0 and x equals -2. Very good. So this will be the graph. In fact, this approach that I'm going is a moderate approach, very, very moderate. Y-axis, and this is x-axis, and this is possibly the origin. So you can see that the curve will cross the x-axis at where x equals to 0 and where x equals to 2. But we know that because the coefficient of x squared is minus, it indicates that the curve will have a maximum turning point. So the curve that you are looking at should be something like this. Now, so here is 0, as we know, and here is 2, as we know. Now, if you watch closely to the inequality, you can see that look at the inequality. This specific inequality shows it is less than sign. Less than sign indicates that that portion of the curve below the x-axis. Listen to very carefully, because most of our analysis will base upon that. Because the inequality, this expression at the left-hand side is less than 0. Less than 0 will indicate that the values of x that we are looking for, they are those values below the x-axis. So it will be this one. So you can see that then this portion and this portion are the values of x that we are looking for. What is the value of x from this portion going on? From this portion going on, the values of x are those values where x is greater than 2, because they keep increasing. They keep increasing. Look at the curve from this side going. Now, if you come to here, you can see that the values of x, where the f of x, where the curve is below x-axis, they are this region. So this region is x is less than 0, which indicates that the set of values of x for which this inequality 2 over x is less than 1, those values are s is less than 0 and s is greater than 2. Then let's put something down. Hence, the values of x for which the given inequality 2 over x is less than 1 are these values: x is less than 0 and x is greater than 2. Can you see the board? I believe you can see. Yeah. These are those values of x for which the inequality is valid. That is another way of doing it. I would suggest that you take your time to copy everything as you see on the board. And then, once again, I'll come back and wipe everything, and we'll use a different approach to solve the same question, to have the same answer over there, the same answer being s less than 0 and s greater than 2. Then at this time, I would like you to take your time, go through everything systematically. And I mean, take your time to copy everything, pause the video, take your time to copy everything, and then we'll come back again. When I come back again, we are solving the same question but by different approach, and an alternative version of solution. We have over there 2 over x is less than 1. As I said, we will multiply both sides by x raised to the power square. In that case, we have 2 over x less than 1. If we multiply both sides by s squared, it will be like this. This is my 1. It is a typical way Germans we used to, it's a typical way of writing 1. If you live in a place, if you live in Germany or in Austria, that is how we write 1, like this. Okay, multiply both sides by s squared. In that case, we will have, algebraically, we have 2x less than s squared. Very good. Then we will bring the x squared to the left-hand side, being positive over there. Once it crosses the frontier, it becomes negative. In that case, we have minus s squared plus 2x is less than 0. Very good. That is not a big deal at all. Then I will say that we are going to multiply both sides by negative 1. Good. If we multiply both sides by negative 1, we have s squared minus 2x less than 0. Very good. Good. You can see that this expression is f of x, almost. So, we can see that when the left-hand side is f of x, then this expression becomes f of x is less than, oh, sorry. Wait a bit. We are multiplying both sides by negative 1. Once we multiply both sides by negative 1, instantly the sign will change. So we have greater than 0 then. Let me repeat myself again. If we multiply both sides by negative 1, in that case, the left-hand side becomes s squared minus 2x. Instantly, the sign, the less sign changes to greater sign. So we assume that the s squared minus 2x is equals to f of x. Then when f of x is greater than 0, then what kind of curve do you think we can have? If we have a quadratic curve where f of x is equals to 0, then assuming the quadratic curve will be like this, then when f of x equals to 0 will be that portion of the graph above x-axis. That portion of the graph above x-axis, this point. Previously, as an example, I'm saying it here. When you have f of x less than 0, and assuming the graph looks like this, then when this one is f of x and this one is x, when f of x is less than 0, then we will consider that portion of the graph below the x-axis, this portion. Yeah, this portion. So take your time, copy this one, maybe at the side of your notes. Let's call this one alpha, let's call this one beta, let's call this one alpha, let's call this one beta, the roots. You see, I will wipe it anyway, but maybe at the side of your jotting note, you can jot this quickly jot this one down. Whenever f of x is less than 0, we will consider the lower portion of the graph that is below the x-axis. Whenever f of x is greater than 0, then we consider the upper portion of the f of x graph that is above the x-axis. That was the point of illustration. Now, having illustrated that, then we'll move on to this point. Yeah, I paused the video just to wipe the other session. Now, on this equation, we see that the f of x is greater than 0, which indicates we are going to consider the upper part of the curve that is above the x-axis. In that case, if we are going to sketch, you just pick this equation. I don't want to go by complex route. Of course, we can do so many things about the left-hand side equation. From the left-hand side equation, we can find where the curve will cross the x-axis. We can also find y minimum or y maximum. We can also find the symmetry. There are many things that we can find. This is it. So, and then finding the symmetry, we can go by long approach and we can go by short approach. Those approaches that in our previous tutorial I dealt with in much detail. This is it. So with this one, just a simple approach, you can see that. Bring this equation here. You can see that x squared minus 2x. This is a quick work we are trying to do. If we factorize x outside that equation, we will have x minus 2 equals 0. This is a quick way. We are not taking from here. Just a quick way to see where the point of intercepts will be. So we can see that s equals to 0 and s equals to 2. In that case, now let us do the nice sketch. The nice sketch, we know that at this time the coefficient of s squared is plus 1. So this curve will have a minimum turning point. So it will be like this, something like this. Intercepts are 0 and 2. So that curve will be something like this. And it will be like this. This is f of x, and this is x. Very good. And because f of x is greater than 0, then we will pick up those values of x that are those values of x or those values of x that are above the x-axis. So the curve is going this way. We are considering this part because f of x is greater than 0. we are considering this portion, this portion, this portion. What do you see? This way, we see that, okay, here is 2. We see that x increases, x increases, x increases, x decreases. So here, x is greater than 2. And here, x is less than 0. So these are the inequalities. So we can see that the inequalities, we can say that the set of values for which two over x less than 1 are x less than 0 and x greater than 0. These are the inequality, the set of values for which this expression is less than 1, exactly equal to what we had previously. Okay, I think we'll take the advantage because honestly, if you have a typical advanced level mathematics questions at this stage, they normally don't ask they normally don't ask the question or the questions in such a simplistic way. Sometimes they will add some other questions on top. For instance, they will ask you to find the y minimum, and they will also ask you to find the symmetry of the curve. Of course, the symmetry of the curve is here. This value. They may ask you to find the symmetry of that curve. But remember, in those days, I showed you a short version of finding symmetry. That is, S equals to negative b over 2a. You can find the symmetry. And the y minimum or y maximum, I told you in those days that y minimum or y maximum. Let me see let's see this thing, whether you can see it. Quite unfortunate. I don't think that you can see it. So, let me draw it here for you to have a clear view. Assuming this is the graph, and assuming it goes this way, this is the symmetry. The symmetry, this point is negative b s is equals to negative b over 2a. And the y minimum, I call it, the y minimum is b square, no, wait a bit. Y minimum is this point. Y minimum is 4ac minus b squared over 4a. So this is the y minimum, this point. And this is the symmetry. And this is the f of x or y, f of x or y. F of x. And this is the x-axis. And this is the origin. So, assuming in this question you were asked to find the symmetry of the curve, this is just such, once you memorize this one, that is symmetry. Symmetry is equal to negative b over 2a. In fact, in our analysis in quadratic equations, we derive them, all these terms, we derive them. This is it. So x, the symmetry occurs at negative b over 2a. Now, if you come here, this is the quadratic equation, the given quadratic equation. It was given as f of x equal s squared, minus 2x greater than 0. Comparatively, you can see this is comparatively this is very much identical to as squared plus bx is greater than 0. Comparing the coefficient of s squared, we can see that a is equals to 1, and then b is equals to minus 2. If you are finding the symmetry, then the symmetry will be x equal negative b over 2a. What is b? b is negative 2 over 2a. What is a? a is equals to 1. So the symmetry occurs at where s equals to 1. This will be the symmetry. Now, what about the y minimum? The y minimum being y, let me see whether you can see it. There, minimum is 4ac minus b squared. 4 times 1. There is no c value there, so it will be 0 minus b squared, where b squared will be 4 over 4a, where a is equals to, can you see it? Let me see my screen. Yeah, you can see it, where a is equals to 1. So if you do your algebra, you can find that y minimum is equals to, this one is equals to 1, while the symmetry occurs at s equals to 1. So you can also see that at some point they may ask you in questions, they may ask you find the coordinates of the turning point. Honestly, the coordinates of the turning points will be negative b over 2a, 4ac minus b squared over 4a. These are the coordinates of the turning point. So we calculated and we saw that the symmetry occurs at x equals to 1. We also calculated over there and we found out that y equals to 1 as well. Therefore, the coordinates of the turning point of this resulting equation is this one. This is it. This was just, a recapturing on what we've done so far. But the whole question about the whole question of this point is that we are just to find a set of values of x for which 2 over x is less than 1, which we came to this conclusion. All these that we added They are bonus that we added. Now, you take your time to copy everything, as I'm going to stand aloof at this side to make the board clear to you for you to copy everything. And then I'll wipe off the board and we'll take another question again. Take your time. Okay, welcome back again. This is also another question that says that given that x is not equal to 0, now in this question that one is not there. Let the real thing be the real thing. In this question specific, solve the set for this the set of values of x for which 5 is greater than 4 over x. Well, the solution way is still the same as what we did previously. So you pick out that equation 5 is greater than 4 over x. Then you multiply both sides by x squared. In that case, we have 5 being multiplied to x squared then we'll have greater than 4 over x and multiply to x squared. That is algebraic manipulation anyway. Multiply both sides to a with x squared, it doesn't affect the equation. By any means, they can still cancel out. So we'll be left up with 5 x squared is greater than 4x. We bring the 4x to the left-hand side. Being positive over there, it will become negative at the left-hand side. So we have 5x squared minus 4x is greater than 0. As I told you, assuming this one is f of x, it indicates that f of x, which implies f of x is greater than 0. This will be very important for us later on after sketching the graph. So this equation, as you see there, we can factorize x outside. So it becomes x 5x minus 4 less than is greater than 0. So you have s equals to 0 and x equals to 4 over 5. Now this inequality is very important. It is the same as this one. Now if you look at the quadratic equation, you can see that the coefficient of x squared is plus 5, which indicates that the curve will have a minimum value. So the curve of such quadratic equation, having the x-axis intercepts at s equals to 0 and s equals to 4 over 5, that curve will look like something like this one. This is f of x, and this is x, and here is 0. Now, because f of x is greater than 0, then the x values that we are looking after will be those values where f of x rises above the x-axis. So it will be, we'll consider this section, the upper part, because f of x is greater than 0. This portion this portion. So on this side, we can see that the x values are less than 0. And on this side, we can see that x values are greater than, this one was 4/5. Is greater than 4/5. Very good. So, the set of values of x for which this inequality is valid is, okay, hence, the set of values of x for which the inequality 5 is greater than 4 over x are x is less than 0 and x is greater than 4/5. Good. Then we are done. What about in the question, if they had asked you to find, number one, they can say that find where the symmetry occurs. 2, find also where the y minimum occurs. Of course, the symmetry, you can see on the board, which is good. This is y minimum. Y minimum is equals to 4ac minus b squared over 4a. Can you see it? I believe you can see it. This is y minimum. And the symmetry occurs at where x is negative b over 2a. And you can see also that the coordinates of the turning point is minus b over 2a, 4ac minus b squared over 4a. Let me see whether you can see it. Yes, you can see it. Very good. This is the coordinate of the turning point. So, assuming you were asked to calculate the coordinates of the turning points, then this should be that one. And assuming you were asked to find the y minimum, then this should be this one. Assuming you were asked to find the symmetry where the curve, is divided into two equal portions, it is this one, b over negative b over 2a. Of course, you know what a is and you know what b is. The question is, what is a and what is b? From this equation, the quadratic equation, we find out that f of x is equals to 5x squared minus 4x, very much identical to ax squared plus bx. C is equal to 0 then, because we don't have any constant. The curve doesn't cross the y-axis at any given point apart from the origin. So from here, comparatively, the coefficient of x squared, a equal to 5, whilst b equal to minus 4. So whatever you are requested to calculate, it could be y minimum. Then it should be this one, 4ac minus b squared over 4a. But obviously, we don't have c. C is equals to 0. Therefore, you put the c equal to 0. And the y minimum will become minus b squared over 4a. And obviously, the symmetry occurs at minus b over 2a, where you know the b to be negative 4, where you know the a to be a. This is it. So, assuming you were additionally asked to calculate the coordinates of the turning points, then you would have done it. And assuming you were asked to calculate the symmetry, then you could also have done it. So then so far we have finished this question. Take your time as I'm going to stand aloof at this side to give you a clear board. In order for you to have a clear board to copy everything, you can pause the video and then copy everything. And then we'll take the next question. Well, this is the next question. I mean, you can see that it is becoming more funnier. I mean, we can feel the fun of it, because it is not difficult at all. I mean, the strategy is always the same. For instance, I mean, this question, you have 1 over x plus 3 is greater than 2. The same strategy that we use. For instance, this one became 1 over x plus 3 greater than 2. You just have to multiply both sides by a square. So it becomes 1 over x being multiplied to s squared. Then we have our plus there. Then we have our 3 there being multiplied to s squared. Then we have the greater sign over there, which is this. Then we have 2 there. Then we multiply the 2 by s squared. So this one becomes x plus 3s squared is greater than 2s squared. So we can have 3s squared plus x greater than 0, which is x 3x plus 1 greater than 0, which is has the factors of s equals to 0. X equals to 0 and s equals to negative 1/3. But we can see that if this is f of x, this part is f of x, then we see that the f of s is greater than 0. So the curve will be either y equals to f of x, this is x, 0 and 1/3. So it will be this will be the minus 1/3. This will be 0. Because f of x, which is this one, greater than 0, it will be this upper portion of x values we are going to consider. Here, x is greater than 0 because from here it moves, increases. And here, x is less than 1/3 minus 1/3. Therefore, the sets of values for which 1 over x plus 3 greater than 2 is or are x is less than minus 1/3 and x is greater than 0. Yeah. That's it. That was a quick one. Very good. Very good. Take your time. The same way, I mean, you can find the symmetry, which is negative b over 2. And you can also find the y minimum, which is 4ac minus b squared over 4a. And the symmetry is negative b over 2a. And the turning point coordinate is negative b over 2a. And then 4ac minus b squared over 4a is the turning point coordinates, where this is the symmetry. Good. Then we are done. Now take your time to copy it, and then possibly we'll take another example. Take your time. I come back. This is also another question. It is the same. So this one becomes 6. You multiply it to s squared plus 5 over x be multiplied to s squared, and the greater sign over there, 8 over x, be multiplied to s squared. So we have 6s squared plus 5x greater than 8x. So we have 6s squared plus 5x minus 8x greater than 0. We have 6s squared minus 3x greater than 0. We factorize 2 outside, so we have 2x 2 times 3 s. Oh, we said that we will factorize 2x outside to make it shorter. 2x, now it is impossible, because now it's impossible. We factorize x outside. It will become x, sorry, yeah, x. But we can still factorize 3 outside, 3. So it becomes 2x minus 1 greater than 0. Very good. Dividing both sides by 3. If we divide both sides by 3, we will have x 2x minus 1 greater than 0. We call this one f of x, which indicates that f of x is greater than 0, which should be very important to us. So the factors of x, when assuming when the curve crosses the x-axis, will be x equal to 0 and 2x minus 1 equals 0, which indicates that x is equal to half. Good. Then that curve will be this one. y x. Good. Here is 0, and here is half. But remember, f of x is greater than 0. Then it will be this portion that we are going to look after. These portions. On this portion, x is less than 0 in this portion. And in this portion, x is greater than half. Therefore, the inequalities, let me write it here. Therefore, the inequalities, or the values of x, the values of x for which 6 plus 5 over x greater than 8 over x therefore the set of values, the values of x, the set of values, are s less than 0 and x greater than half. Good. Then we are done. In the same thing, here's the symmetry. Here is negative b over 2a. And here is y minimum, which is 4ac minus b squared over 2 over 4a. Yeah, y minimum. Very good. Take your time to copy it, and then we'll take another example. As you can see that it is becoming funnier. So simple. Take your time, copy, and then we will take the next example. Yeah, let's consider this question as well. This one becomes 25. We multiply both sides by s squared. Then greater than 1 over x squared. And then multiply to s squared. We'll be left up with 25 s squared. 1 over s squared multiplied to s squared. They cancel out, so it becomes 1. Now, this one, we can say that, assuming this is f of x, then it will be that f of x is greater than, f of x is greater than, wait a bit, for the meantime. This one, we can straight away write it this way. It becomes s squared is greater than 1 over 25. We have x is greater than plus or minus 1 over 25. Good. And then this one becomes x is greater than plus or minus 1 over 5, being here x is less than minus 1 over 5, and here x is greater than 1 over 5. Therefore, therefore the set of values of x for which 25 is greater than 1 over x squared x is less than minus 1 over 5 and x is greater than positive plus 1 over 5. Good. And that's the other one, a quick one. Take your time to copy it, and then we'll pick it up from, we are going to pick the next question, possibly the last one. So take your time to copy everything, and then we'll come back again with the next question. Why come back again? This is another question. I mean, it is becoming funnier. So this one becomes 6 over s squared. We multiply both sides by s squared anyway. This becomes s squared plus 7 over x multiplied to s squared is less than 3 multiplied to s squared. So this s squared and s squared will cancel out. So we'll be left up with 6 plus 7x less than 3 s squared. Good. 3s squared. Good. So we can do it this way by saying that we are bringing the 3s squared to this side to make it more simpler and more reasonable. So we have minus 3s squared and then plus 7x plus 6 is less than 0. We are going to multiply both sides to make our life easier. We are going to multiply both sides by -1. In that case, we have this one to be 3s squared minus 7x minus 6. As soon as we multiply both sides by -1, the sign changes. So at this time, it becomes greater than 0, which indicates that is there a space there? Which indicates that assuming this one is f of x, yeah, then it will indicate that f of x is greater than 0. Good. We are going to solve this quadratic equation. We'll multiply both sides, or we'll multiply the coefficient of s squared to the constant. If we multiply the coefficient of s squared to the constant, we have minus 18. Then we figure out minus 18. What factors can we have in order for minus 18 in order that we can have minus x? Yeah, then you use your quadratic strategy to factorize. Good. 3 multiplied to minus 6 is minus 18. But maybe, let me do it here. 3 multiplied to minus 6, you have minus 18. But honestly, minus 18 is also no different from minus 6 times 3. It is also no different from minus 9 times 2, whichever. But from these two, which one of them is relevant if we add them together? If I add minus 6 to plus 3, I'll have minus 3. Is the coefficient of x minus 3? No. Then no. This one is ruled out. If I add minus 9 to plus 2, I'll have minus 7. Is this coefficient over there minus 7? Oh, yes. Then it indicates that this is a suitable factor. In that case, this quadratic equation being 3x squared minus 7x minus 6 is very much identical to 3x squared minus 9x minus 2 plus 2x minus 6, all greater than 0. So this one becomes, factorize the 3x out, have x minus 3, and the same x minus 3, I'll write it here. So this one can say that multiply to 2 greater than 0. So this one becomes 3x, factorizing the common factor out, have 3x plus 2, and then x minus 3 greater than 0. This one is 3x squared minus 7x minus 6. Good. Okay. Where the curve will cross the x-axis, 3x plus 2 will be equal to 0, and then x minus 3 will also be equal to 0. So we'll have 3x plus 2 equals 0, and x minus 3 equal 0. We have x equal minus 2 over 3, have s equal 3. So we are now going to take on the curve. The curve that we are trying to sketch, we know that in that curve, the quadratic equation f of x here is greater than 0. So that quadratic curve, maybe, is this something that we can write it here? Yeah, let's see. Oh, let me do it here. So, minus 2 over 3, that curve will be something like this. In here, can you see it? Yeah. Oh, possibly. Take your time to copy it, and then I will take this section off. Oh, what do we do? Oh, let me use different color then. This section is where x is less than minus 2 over 3. This section going this way. And this section going this way. This one going this way is where x is less than minus 2 over 3. And this is where x is greater than 3. This is the symmetry. This is the y minimum. Negative b over 2a. Good. So the y minimum, we know it to be 4ac minus b squared over 4a. Good. So the inequalities, the set of values of s for which this inequality is valid is where x is less than negative 2 over 3 and where x is greater than 3. So where do I write it? This is what I'm thinking. Good. Okay, let me dictate it for you because the board is fully completely filled up. So the question says that given that or find the set of values of s for which 6 over s squared plus 7 over x is less than 3. So the answer is for the given inequality, write it down as I dictate. For the given inequality, x over s, 6 over s squared plus 7 over x is less than 3 are the values where x is less than 2 over 3, which is this one, and x is greater than 3. That are the sets of values of the inequality for which this expression is valid. Now, you will take your time to copy everything as we've demonstrated everything. And thank God for today's tutorial. It has been such an eventful and celebrating. We thank God for the opportunity and the knowledge that He gave it to us, and for us to come to such a plausible and celebrating conclusion. We thank God for that. Now, the Lord Almighty, God bless you, keep you, make His face shine upon you, lift up His countenance upon you, and give you peace. Shalom. God bless you. Amen. I'll see you next time.